Thompson,
You're both with the Meadow Center for Water and the Environment at Texas State University.
and this is Fahrenheit 140.
Well, hello, everybody, and welcome to episode 3. How are you today, Carrie?
Hey, Robert, I'm good. Happy holidays.
Thank you. You too. I have just good news. I have
Let's
lots
hear
of good
it.
news.
I want
Well,
to hear it. All of it.
just good news articles to talk about, and I've
Oh,
been
nice.
feeling good about things. And I'm going to save that to the end in terms of like why I've been feeling positive about the world and good about things. And it's not just my caffeine intake. It's just kind of new information, I guess.
You want to share your
Um,
new identity, the word that you discovered?
what? Oh gosh, I forgot all about that. um,
The
I forget.
apocalyptimist?
Apocalyptimist. Yes, I was thinking, what was that? It's like a snuffleupagus in Sesame Street, but an apocalyptimist. which yeah, I saw on Facebook, some goofy meme, and apocalyptimist was and I don't have it in front of me, but it's like the world's ending, but you feel okay. It's like that REM song, right?
Yeah, that's right. I feel fine.
I feel
It's
fine.
the end of the world. I feel fine.
Or it's like things are going to hell, but I feel optimistic about things. I think that's what I would call an apocalyptimist.
It's a good. I'll make that our episode name.
Apocalyptimist, adapting to climate change. So
What'd you
you've been
find?
you've been reading the news. You want me to go first?
Yeah, I'd love to hear what you
Okay.
found. Let's hear why you're
Well,
so upbeat. Bring me to your side. Bring me over.
Okay. Yes, I know. This will be hard. So interesting article, and I'm a big fan of a online news service called The Conversation, and not just because they published one of my articles, but it's I was actually discovered them during the pandemic, and they're a little unique in that they merge, or they bring together academics and reporters, and then the reporters help the academics write up their research or write up a technical topic for the people, and so appreciate that, because it's like going through the pandemic, I really do want to hear from the experts, and so there's an article by Philip Stalley of DePaul University, and it was an article via The Conversation, and the title is "In the Fight Against Climate Change, China is doing more than you think, but still not enough." And I think and certainly I hear it from my friends across political spectrums. China is a big emitter of greenhouse gases. They're 30% of the world's emissions. And Dr. Stalley noted that China has had mixed results so far, but thinks they'll do more in the coming years. And he also notes that a common misperception is that China either lacks climate policies or fails to implement them. The reality is that China has a robust set of climate and energy policies and a strong track record when it comes to fulfilling its pledges to the international community. But his criticism is that they show a lack of ambition. So they're not putting in stretch goals, but the goals that they do put in, they do tend to meet those goals. Versus a lot of folks that are countries that make goals and then are doing very little to achieve them. Some other interesting little tidbits he had was like half the world's electric vehicles and 98% of electric buses are in China.
Interesting.
And it achieved 9 of its 15 quantitative targets in its 2015 climate commitments ahead of schedule. So they're maybe kind of a aim low and succeed. I guess maybe you could also, you could argue they're not aiming high enough, which Dr. Stanley is saying that, but I think you could also argue they're trying to choose goals that they know they can meet. And over the past decade, their use of coal has fallen from about 70% of its power generation to 57%. And a lot of that is, they're world leaders, quite frankly, in renewables, and they're also converting to natural gas, which is kind of an evolution towards green energy. It's big reason the United States' emissions have gone way down is more because of cheap natural gas. But as we all know, that's not enough. So yeah, that's good, helpful, hopeful news. Wouldn't you agree, Carrie?
Oh, I'm very much apocalyptic about that. Mine ties in a little bit. My first one, I'm actually going to do a twofer because I want to, end it on a happier note. So the first one is out of the Washington Post, and I actually like the subtitle better than the title. The subtitle is "The Cost of Dithering." And the title is
Mm-hmm.
15% of all U.S. greenhouse gas emissions have happened in the last decade. And so I just really pulled a few little factoids here, but this one was pretty jaw dropping. So since the release of Al Gore's An Inconvenient Truth, right? We all remember that, the charts,
Mm-hmm.
the PowerPoint,
Yeah, that went off the yes.
yeah, 2006, right? 40%. Global emissions have increased by 40% since that PowerPoint. That's crazy to me. That's so
Yeah, that is
crazy.
crazy.
And it says no country has contributed to those emissions as much as the United States, which is, I know that's kind of the controversy. And then the comma, though China has added more in recent years, and their rate of increase is much higher because of their
Mm-hmm.
where they're starting, right? But cumulative global emissions have jumped more than 26%, with the U.S. increasing by about 15 in the last decade. So that's kind of a downer. So I wanted to marry that with this other article. So
We make such a good team,
I
Carrie.
know you're really turning me around. So.
I blow up the balloon, you let the air out. Now
I can't believe this. That's not nice.
it's okay. It's okay. Um,
But this is a little story out of the UN about their own. It's like their own workforce
mhm.
and what happened to their greenhouse gas emissions during the pandemic. So
This is China,
no, UN, the UN,
U.S. Oh, UN.
the UN, yeah, United Nations. They have, I think, 315,000 employees, which I was pretty shocked by that, and then 56 offices. It looks like, and kind of taking a look at what happened in 2020, they generated 25% fewer greenhouse gases just because they shifted to more telework
Hmm.
and
Wow.
really focused on um, carbon offsets, and we're going to talk more about that in the later
Hmm.
in the episode. But I thought it was inspiring, and it also sort of just shines a light that you know we can change the way we do business, and it can have a real impact. 25% drop in 1 year is pretty incredible. Against the
Hmm.
backdrop of all of that increase, we really still do have um, we still have tools that really could make an impact. And not only did they change their carbon output, but their water use, and basically says, this highlights an opportunity for us to look at how we work and travel and, um, change the kind of emissions that we're having. So,
And who knows what's going to happen with Omicron, but setting that aside, as we've been um, transitioning to, one would hope at some point a post-COVID world.
mm,
Um, what's been occurring to me is that how do we use this new video technology going forward, and really to the benefit of things. So like with our own blue bag, which is what we call our monthly kind of brown bag lunchtime presentation, And we're a bit off of campus, so it's difficult for professors on campus to attend in person.
Mm-hmm.
And my thought is, and we've got friends of the Meadow Center all over the
Sure.
state. I'm like, let's do these virtual. And the attendance is a lot higher. I just participated in the Texas Water Research Network meeting, and it's a similar thing. I'm encouraging them. I'm like, we should have. There's something to be said about getting together in person every once in a while, but an organization that tries to pull in academics and water people from across the state, you're more likely to get more involvement in a virtual setting, and so they're gonna look at that and probably do something like that. So I imagine a lot of that decrease in carbon footprint for the United Nations, 315,000
I
people.
know, right?
Jeez, is
Yeah.
this is not jet setting around?
It's kind of
Um,
right, right, exactly. And it is, they do have a obviously international presence, so I'm sure they do travel a lot or did. How's that, Robert? Did that bring you up?
um, yeah, that's
That's
good.
pretty good, right?
I
Pretty
mean,
good.
you do your thing, but you're
Oh my god,
what?
it's so unfair.
Um, so, so the San Antonio Express News published a commentary um, written by Meredith Scott, who's a sustainable rancher here in Texas, and
Hmm.
then I might have gotten the names wrong because I got Suzanne Scott here, and I don't think they have the same last name, but Suzanne Scott, who's the head of Nature Conservancy in Texas, and the title of the article is how ranchers fight climate change. And if you're listening, if you go back to the podcast, we do provide links to these articles. Unfortunately, this one with the San Antonio Express News is behind a paywall.
Hmm.
Meredith Ellis, yeah, I got her name wrong. Um, but it was basically how ranchers play a role in um, carbon sequestration and with the environment. And so it's a discussion of, there's a U.S. Department of Agriculture's Climate Smart Agriculture and Forestry Partnership Initiative. So
Hmm.
helping working, lands and those that own them to manage them in such a way that it stores carbon in addition to absorbing and filtering water, which is good for the cows, but also good for the plants and native wildlife. Expressed concern about how much land Texas is losing, how much working land is being losing to non-agricultural use. I'm sure these numbers come from Roel Lopez's work at A&M, but between 1997 and 2017, Texas lost about 2.1 million acres of working lands, and then there's been a significant acceleration in that decrease, which we see. If you live in an urbany part of Texas, like we do, you see that growth going out into the countryside, and so Texas loses 650 acres of working land per day,
Whoa.
essentially due to development. And of course, that has carbon impacts. And then this little article also reminded me that there's a group called the U.S. Roundtable for Sustainable Beef and the Food and Agriculture Climate Alliance. So there are organizations out there to help ranchers think differently about how they're doing their business, but then also seek to give the industry credit for what they do in terms of um, hosting what is really the source water for a lot of urban areas, and then also maximizing what they can do to store carbon.
Absolutely. Absolutely. Every acre that's not converted to development is good news for us. That's awesome. All right, this one, if nothing else gets you in climate change fighting mode, this will. Are you ready?
I'm ready.
I mean, I was pretty moved by the article we talked about where coffee was endangered by climate change. But
Them's our fighting words.
yeah, right. This one's just as touchy for me. Climate change, ready?
Hmm.
Making Texas allergies worse faster than anywhere else in the United
Oh my
States.
gosh.
I know. Texas. Why? Why? This is from beloved Austin weatherman David Um, Yeomans. I'm not sure how he says it, but let me read the bad news to you here. A 2021 study found that Texas is seeing a faster increase in springtime pollen than anywhere else in the country. Tree pollen in the spring had one of the largest increases, starting about 20 days earlier. So the season lasting at least 20 days longer,
Oof.
and an average across the board increase of 21% concentration. I mean, I don't know if I can take it.
That's just rude.
Yeah, get that and here. Just I mean, I love this article because he's really bringing it home to people. He says, also, since 2007, more CO2 in the atmosphere is leading to bigger, more aggressive poison ivy plants. This trend is expected to continue unless we curb our emissions. So there you go.
There you
That
go. Wow.
that is a change maker right there, don't you think?
Yeah, yeah. That's amazing. Yeah, one of my friends, he's critical because there's a lot of news articles out there about tying everything to climate change. And what I tell him is just like, all the bad things that happen in the world aren't because of climate change, but it just kind of seems to make things worse.
I would say like not all, but most, right?
Most, yeah,
Just
yeah, yeah,
yeah. Well, see if he can tell you that through his sneezing and crying because
and itching, and itching. Yeah, yeah.
I know.
Poison ivy.
Yeah.
That's just not good.
I mean, I give this article 5 stars for persuasiveness. So
So, um, so my third article is a cool one. This one literally is is it's titled "Cooler Pavement Coming to San Antonio
ooh,
Streets."
nice.
It's by Gregory Pollack of Fox 29 in San Antonio, and what it is, so for me, it's like the no, I'm gonna stop because you're gonna. These are the articles that come to me, and it's probably because I'm happy about things. So,
I know. What are you doing?
see, I should have stopped.
Gosh.
Um, so the this company is testing. Well, let me step back. I was at a Texas Water Research Network conference earlier this week, and in fact, those of you that are out there, Texas Water Research Network, it's hosted by Jay Banner's research group, the Environmental Science Institute at UT. It's mostly directed towards scientists, but if you're interested in science, or if you're an advocate in geo, you can join it. But one of the presenters there, and the meeting was a big about equity and particularly water infrastructures. But somebody said that, which was amazing to me, was that if you compare temperatures in neighborhoods in Houston from the poor part of town to a wealthier part of town, the poor part of town is like 17 degrees warmer. 17 degrees warmer.
That's
And and a
unbelievable.
big part of that is tree canopy and things like that. Where if you don't have all those trees, you just have these big solid surfaces, you get asphalt that's just absorbing a bunch of heat. And so what's going on in San Antonio is they're part of a pilot project that's also being done in Los Angeles and Phoenix to put sealer on the streets, which is something that is commonly done. Like you'll see road construction workers put sealer on top of of asphalt to kind of fix cracks and put things into place. But instead of it being black like it usually is, it's stuff that they were doing. It was like a light concrete color, and saying that it can decrease the surface temperature between 9 and 12 degrees using this stuff. So I thought that was kind of a cool, simple thing that communities could do to reduce the heat island effect, where the temperatures are higher in our urban environments, because we don't have as many trees, and we have a lot of dark surfaces. And if you're interested and I'm not too familiar with San Antonio, but the Hayes Street Bridge, it's on the east side. Looks like they did about a block there, and they're collecting data on what it
Oh,
means and what it
cool.
does.
I've heard a little bit about this in some cities trying to plant trees in areas where they have heat island issues,
Hmm.
but areas with a lot of renters have trouble with kind of maintaining trees, and then the cost of water and
Good
watering
point.
trees is
Hmm.
it's there's some systemic barriers to some of these changes. So it's great they're thinking about it at the municipal level.
And it's if and a big part of that is, speaking from personal experience, is just choosing the right trees. Now there is, when you plant new trees, you do need to be watering them, but once they get established, if you're choosing the right trees, then you don't need to water them anymore. So like at our
Yeah,
place, there it's xeriscaped, um, and so we don't water the trees. Now we did water, there's a couple trees we planted. We'd have to water them for about a year, but since then we haven't watered them. So
nice. All right. My next article is about climatarianism. Have you heard about
I
this?
have not.
I love
Is
it.
this like eating climate
Yeah, it
scientists?
is. Yeah, not eating climate
Oh,
scientists. No. Although, that's interesting. Um, no, it says this is. I found once I read this, I went and kind of searched for it, and I guess there have been articles in New York Times and other places this year about this, but this one's in a Australian publication called Body and Soul, and under their nutrition column, Sophie Scott, and the subtitle is, "Are you ready to see a letter C next to the dairy-free, gluten-free, and vegetarian labels on your menus?"
hmm.
I thought that's really interesting, and so I just thought I'd share. Climatarianism is kind of taking off. People are trying to think about the carbon impact of their food,
Hmm.
and so I wanted to share some of the pointers or sort of the
Cool.
pillars of climatarianism in case you want to start putting a C on your menus. So it says carbon labeling may become as common as nutrition labeling. And according to the UN, an estimated 30% of all food produced for human consumption never makes it to the plate. And we throw out about 20% of the food we buy. So some of the principles are, don't waste food. If you can, if it's kind of getting outdated, throw it in the freezer or pickle it or throw it in a stew. Try to find ways to use it. And for those of you who've kind of looked into that zero waste movement, that there's a cascading kind of theory too. Like if you can't do any of those things, then see if there's an animal that can eat it, and then if an animal can't eat it, then see if you can compost it, and try to stay as high as you can on that
What
chain.
about black soldier fly larva? I mean, that's what we
Mm.
do with.
Somehow this article fails to mention that specifically, but do tell what.
Oh yeah, so I have, and I don't want to say my wife and I have, because she pretty much has disowned them, but I've got, might be, I don't know, might be 500 black soldier fly larvae that I have in a compost out by our garden,
What
and they're
happens when they become adults?
they turn into these really cool looking flies. So like if whoever designed the stealth fighter designed a fly, this is what it would look like.
Huh.
And they're called black soldier flies because they're born without a mouth, and they die within a day. So
Oh,
they're
wow.
pretty much born to party, and then they die. So it's not a fly problem at all. I mean,
Okay.
it's a good day when I see a black soldier fly because they're so cool looking, but it's not a common occurrence. And then so I get these kind of Cheeto-sized maggots that break down stuff
Mm,
pretty amazing. They love coffee grounds and watermelon. Those are favorite
nice.
things. But
Yeah. You are an optimist when you say, "It's a pretty good day when I see."
black soldier fly, it is. It's exciting. It's just like, wow, check it out.
That's awesome. All right, some other quick pointers if you want to be a climatarian is reduce your meat intake. They're not saying get rid of meat in your diet, but just try to see if you can cut it back and maybe incorporate more plant-based foods and eat organic when you can, and not just because it's sort of cool thing to do, but the pesticides and fertilizers actually have a large carbon footprint, which I hadn't thought about. And then trying to scroll. I guess that's it. So it
Cool,
says,
cool.
yeah. Um, so just some things that they're not that difficult to do, and I guess you could lower your impact.
Very
So
good.
that was that one. Be a
Climate
climatarian.
Climatarian. Okay. Well, it's
Climatarian.
good to hear that it isn't about eating climate scientists. So
It is that is comforting.
I bet there would be a subculture at some point. Um, all right. Well, next up, we've got
It's good
Dr.
news. Time for good
Yes, it is
news.
good news. Something cool that's happening in Texas, and we'll hear from Dr. Sue Hovorka. Welcome back, everybody, and we're pleased to have Dr. Susan D. Hovorka. Sue, I've worked with Sue a long time. I guess I first met you, Sue, back in early '90s. She is a senior research scientist at the Bureau of Economic Geology, which is with the Jackson School of Sciences, which is with the University of Texas at Austin. I did a little Oppo research on her, and I didn't realize this that you have a BA in geology from Earlham. Is that how you say it? Earlham College in Richmond, Indiana. The what is it? The Fighting Quakers? That doesn't seem right.
It is, yeah.
It is.
Something like that.
That's kind of cool. Are you from Indiana originally, or?
No, my family has a farm in Indiana. We're putting it in solar power. So let me say that to establish my cred as a green thinking person.
That's awesome. Well, after getting her undergraduate degree in geology from Earlham, she got her master's and PhD from University of Texas at Austin. So welcome to the show.
Thanks, Robert.
Nice to meet you, Sue.
Nice to meet you, Gary.
You've been working on some really exciting things, and on this podcast, we're focused a lot on water, but I guess just really anything generally with climate, and particularly if there's a Texas connection to it. And I know you've been working. It seems like you've been working for at least a decade.
I was working with you in the '90s on the Edwards Aquifer, which I love. I loved it. Working on the Edwards Aquifer, and for a little, you remember that little holiday that the Edwards Aquifer research took when they had to reconstitute the Edwards Aquifer Authority?
Yes.
Yeah. So, and at that point, I got involved in this new thing about climate change. Is it real? Is it not real? And at first, I thought I'd work on climate change research, on looking at the role of climate change in modifying groundwater and lakes and the high plains and so forth. But I ended up getting involved in mitigation. Like, okay, climate change, let's not study it, let's stop it. So, so then I lost my Edwards Aquifer career by distraction. I mean, Edwards Aquifer is still very important, and I wish I was working on it. But this bit about what can we do to preserve recharge, to preserve lakes, preserve environmental quality in the face of human created climate change needs attention. So that's what I'm working on now.
Carrie, it looks like you have a question. That's
Well,
my
we are.
secret prompt.
Yeah, thank you, Robert. That's so subtle. Yeah. Well, Sue, we wanted to have you here to talk about CO2 sequestration and just help folks understand what it is, why it matters, what's the promise, what are the worries. So maybe just start with what it is.
Yeah. So the idea is that we're perturbing the climate by putting all the CO2 that used to be stored as fossil fuel, coal, oil, gas, in the subsurface. We're bringing it up the surface, extracting energy from it to do all our stuff, and letting the CO2 from the results inevitably from combustion of fossil. We're letting it go loose in the atmosphere, and that's one of the big, that with agricultural change. That's the big driver of forced climate change. So a lot of people have talked about, well, we should just stop that. But if you think about your own life, you think about what we're doing now, we're getting it's a nice breezy day. Maybe we're getting 20-30% of our energy from wind, and the rest of it here in Austin, we're getting it from the gas-fired City of Austin utilities. We might be getting it from LCRA. We're using, and it's a night. If the wind's not blowing very hard, we'll be using more. And I have solar on my house, but we can go out and look at the lights. So there's a bit about handling fossil fuel is important. And it's also, so what we do is, instead of releasing the stack gas, we call it a smokestack, a stack in short.
Okay. Stack gas.
That's
stack
very
gas.
snappy.
Yeah. And so the problem is releasing to the atmosphere. We don't do that with wastewater anymore. Since the Safe Drinking Water Act of the 60s and 70s, we used to be you could dump water right out the back door. I could see pictures of Niagara Falls of plants dumping their wastewater right over the edge.
Wow.
We don't do that anymore, and it improved water quality hugely. So one of the things we need to do to improve the air quality with respect to climate, global warming issues is stop releasing the CO2 out of stacks. So the choice is, if you have CO2 coming out of your stack and you need to stop releasing it, you can capture it and compress it and send it off to a safe, approved, permitted place and re-inject it back underground, thereby closing the loop. So we say, I have a T-shirt that says "Put it back," by which I mean carbon. It's like a kindergarten rule. If you got it out, you should put it back. There's an if statement in there. If you don't find it necessary in your life somehow to take any carbon out, you don't have to put it back. But if in your life you're removing carbon from storage, you need to put it back in order to get to sustainable in a carbon neutral world, so that we can attain safe climate scenarios in the future, not for us, because we're talking about the future. But
well, how do you put it back? What does that look like?
So there's what goes up the stack is no longer smoke. It's cleaned up to meet air quality, but the CO2 is allowed to go through that processing. So you add one more gizmo that traps the CO2. You don't want to put the stack gas straight down because it's mostly nitrogen. And you don't want to compress the nitrogen, so you pull out the CO2. It's more convenient to ship it in condensed form because you don't want to carry around all that bulk. So you ship it. Usually you stick it in a pipeline, although you can put it in a container and put it on a train or a boat or whatever suits you. And then you inject it into the deep subsurface below and isolate it from fresh water, so that in a situation where it will be permanently retained. And that's in the law of the Safe Drinking Water Act, 1974. It has to be below, isolated, and that's where the word sequestered comes from. You have to show, before you can even contemplate doing this, you have to show that it's down there to stay.
How deep is deep?
We want it. It needs to go deep enough so that it can't come back up. And that, of course, being geologists, it all depends on what's going on. But in general, it's in 800 meters, nearly a mile. So it's got to be deep enough to be isolated from freshwater. So freshwater can be quite shallow, but many places it goes in the Gulf Coast, where we do a lot of work. It goes down several thousand feet, so you have to go below that, and you have to then have something in between, so there's isolation. Now we're in good shape because the subsurface is layered, so you put it below enough layers, and you can pretty well demonstrate to everyone's confidence that it's not coming back up.
Hey Sue, I'm having a hard time picturing this. So are you is it a big truck of gas and you're just, I don't understand. How does it get in there? How do you capture it and how do you inject it? What does it look like?
So when the capture facility is usually a big thing, there's a bunch of different ways to capture it. Let's talk about the one that I've seen operating in Texas, the one at the W.A. Parish plant south of Houston, and it's a big tower. Looks like a small refinery. It grabs the CO2, then it compresses it. Compressors are big piston-driven things. They usually come in a row, so they compress and compress and compress in stages. Then they put it in a pipeline. Pipelines are usually inches in diameter, 9 inches, 18 inches in diameter. They can be above ground, but they're often buried, and they're sometimes buried. So they go, they're even don't touch the surface. They're tunneled under rivers or under sensitive areas like habitat. Then you get it to the place, and that's what we do. I do is our team at UT helps to define what this place is. It's actually very well established what kind of a place you need. There's sedimentary rocks that we want, those layers that come with sedimentary rocks. So they are layers that have high permeability and low permeability. The connection between the pipe and the well is very simple. Most people have seen a wellhead. That's what it looks like. That's all it is. Pipeline comes up, goes into the wellhead. There's not much sticking up at the surface. It looks like a parking lot with a couple of heavy pipes standing in the middle. It's very unimpressive.
So is it like an underground bottle of champagne at that point, where you got to keep the cork in, otherwise it all spews back, or does it kind of go into the formation and dissolve into the water and whatever?
Yeah, this is a hard thing for people to imagine, because that people think about rocks as being solid, that there's no space. But those of you who work in groundwater, many of your listeners are groundwater people, know that fluid flows through the spaces in the rock. And the spaces that we're talking about are, for the most part, the spaces between the sand grains. Mm-hmm. So the conceptual model you have for groundwater flow, where fluids are moving in between the sand grains. If anyone who needs to think about fluids moving through rock, the flow processes are, you can imagine yourself watering a plant in a pot, right? And what happens to that water? It goes in. Where does it go? It doesn't go in a cave. It goes into the spaces between the grains in the plant pot. Now, if you put in too much, it'll start spilling out the top. If you put it in too fast or too much, it'll spill out. Same with the CO2 that we put underground. So the assessment is, in principle, almost as simple as that. How fast can we put it in and not have it spill out? How much can we put it in and not have it come out the other end? So for that information, we need to know quite a lot about the zone we're putting the CO2 into. It's already full of water, so we can test the behavior of the water using the same ways we test the water well to find out how much water it can produce for groundwater. We use the same basic hydrologic principles to assess how the rate at which the CO2 can be put in and how far it will migrate before it begins to spill out of the area we want to keep it in.
So if it spills out and percolates up into an aquifer, is that then become free Topo Chico for everybody?
we have to, it's hard to describe something because people people alternately get too casual, like Topo Chico, or too anxious, like, okay, but this is like dihydrogen oxide, right? Or this is CO2 going into dihydrogen oxide. It's pretty dangerous, right? So, so CO2, we need to get our level of concern correct. We don't have to retain the CO2 for millions and billions of years. It's okay if the Earth system acts, but we do want to retain it very effectively for thousands of years, so we get the climate value. So, and so it means that ordinary practical geoscience type experience is quite adequate for the purpose. The way that we work with groundwater, for example, will let us work with the deep subsurface. That we need to show that it will be retained in isolation over 1,000 years effectively, but it doesn't have to be absolutely perfect. It has to be good enough to keep it retained. The law says, the Safe Drinking Water Act and the rules under that can include no migration, but I think they often mean no realistic migration. Yeah, 1,000 years is like equal to no. So, and it's not gonna, in 1,000 years is not all going to come out. It's like it might be that if it migrated, the CO2 migrated in a way that you didn't like it, you might be able to detect it someplace you didn't want it. It's not very dramatic. For example, if you go sample the bubbles that are coming up at Edward Springs, they're mostly CO2, and it's not a particularly big problem. We need to keep it proportional.
What about earthquakes? With all the water that gets injected for fracking, and it's allegedly, some would say allegedly, but I would say it has caused earthquakes.
Oh yeah, we know for sure.
So is there is that something we have to watch out for when we inject a bunch of gas in?
Yeah. Well, so welcome to Earth.
Take me to your leader.
Our planet does have energy in the system that expresses itself as seismicity throughout, and but we need to not accelerate that normal seismicity, or either in magnitude or in frequency, in an unacceptable way, which is usually referred to as induced seismicity. So the process of disposing of water has caused earthquakes to increase in frequency and potentially magnitude. We can see that very clearly in the data, so there's no quibble about that. And CO2 can do the same thing. An important thing to notice is that this induced seismicity at measurable or threatening levels doesn't occur everywhere. For example, in fact, it doesn't occur most everywhere. Most places you can inject to your heart's content, and there's not enough energy in the Earth system to release. So you don't get any detectable, measurable seismicity. Now you always get some seismicity is acoustic energy, right, propagating through the Earth system. So when you put the CO2 down, you always, if you put on headphones, you'll and you listen to what's down there, just put a microphone, which is a receiver, to listen to it. You'll always hear something, but we put these in magnitude of -4 or something. It sounds a little bit like Rice Krispies, same process. And in Rice Krispies, you're changing the pore pressure of the wet. As you put milk on it, you're changing the pore pressure of the gas and trapped in the Rice Krispies, and it will break, and you'll hear this noise. So you'll always hear some noise. So people can't hold you to no seismicity, because that's not a thing we can do on Earth. But what we want to do is avoid as consequential seismicity, and most places don't. You can inject vigorously, and you have to not exceed the strength of the rocks, because that will cause more than snap, crackle, pop. They'll start making little booms. You don't want that, but for many reasons. But it's not allowed, and it's courtesy all the experience from fracking. We know quite easily how to measure how much is too much. It's required by the Safe Drinking Water Act that you measure how much is too much and stop short of that, and report frequently that you're complying with that rule. So it's not hard to measure. The place that people get in trouble is if they didn't know how much energy was too much energy, and you have to go test and find out what the state of stress is and whether are features that could be energized that would result in consequential seismicity, usually being something that people standing on the surface can detect. We're not worried about Rice Krispies. We're worried about stuff that are going to bother people or harm people or harm things. So it's for an example of this case that we're doing a project in Mississippi, and a group in Japan who was working on doing CCS in Japan asked if they could test their technology in collaboration with a U.S. program that was a little further ahead. So they were going to work in California, which would have been great. They would have had some good times in California, I think. But the project in California got postponed. So they asked us if they could work with us in Mississippi. And we said, sure, we'd be delighted.
And Sue, what is CCS?
Oh, sorry. We were doing injecting CO2. We're injecting 1 million tons a year and monitoring it we have a project with all of our friends. It's like all the national labs and USGS and groups from abroad, including this group from Japan who want to measure seismicity. So we raise the pressure. It's the injection in this location in Mississippi is at 3 kilometers depth, and it's got several faults in the injection zone. So we're quite optimistic that something interesting will happen. Not hazardous, but interesting technically. And we're going to raise the pressure quite a lot, 1,000 psi above initial pressure above. So that's good. So they put out an array of six nice Japanese designed seismometers and at a 100-meter depth well that isolates them nicely from the surface, and they worked beautifully. They could call us from Japan and say, I see they'd say lightning. We'd say thunder, you mean? So they could detect noise at the surface. Wow. They could detect global earthquakes. And you know what they got out of that site? Nothing. Just nothing. It didn't energize anything to make detectable noise with quite a good array. And that's fairly widespread. That's much more common than the other. It doesn't make the news, but you have to tell the wolf from the sheep in seismicity. So most of them are sheep, but some of them are wolves. Be sure to tell the difference.
So it sounds like you're working in a lot of locations. Is Texas a special place for sequestration, or?
Texas is kind of a special problem.
Ooh, tell us more.
If Texas was a country, it would be, I think, number 7 on the planet for carbon emissions. It's a top ranker. A high carbon emission density because of the amount of processing of fossil fuel, a fairly large population. So Texas has a need. Texas also has the opportunity because the subsurface of Texas, especially in the Gulf Coast, but also in the Permian Basin, have the potential to accept very large volumes of CO2 and with quite high assurance that the storage will be permanent. So it's a need and an opportunity that are coincident. That's not everyone has that.
So I was just curious, who are your customers? Who's doing this, and how common is it as a practice?
So the old processes, things have been injected for almost 100 years, wastewater from oil and gas. So this is a mature technology. Fluids of various kinds have been injected since before the Safe Drinking Water Act. So all kinds of hazardous fluids have been injected and monitored. Most people don't know that because most of the what are so-called Class 1 wells managed by the U.S. Environmental Protection Agency. They've been operating for 50 years and nobody knows because they mostly operate without a fuss. There's also been CO2 injected in very large volumes into oil fields to improve the recovery, and that's a very analogous handling procedure. It gives us a clue. And out of about 100 of them, there's been one that had measurable seismicity. They're still operating it, though they didn't. And it's this Cogdell Field in West Texas. Okay, so that's the old story. The new story is anybody who wants to manage their carbon, which has gotten to be almost everybody. Their phone rings off the wall. We're talking to everybody about everything. Previously, our work was funded almost entirely by the federal government, by the U.S. Department of Energy out of the National Energy Technology Lab, who were charged by Congress to find options. And we worked with our counterparts globally and across the U.S. We're teammates doing this all over the place. But recently, the commercialization has been picking up, and lots of companies have been making announcements and that they're going to manage their carbon in the future. And a goodly number of them have carbon capture and storage, CCS, as part of their portfolio, and they need to know how to do it. So I've had some great conversations with people who call and say, first of all, they establish their cred that they are very competent, well-financed groups that have a significant carbon budget. We're a Fortune 500 company. We know what we're doing. And then they say, so do we have like a subsurface? So there are lots of groups who've never thought about what they could do underground are entering in. So it's a lot of fun working with them. We at UT don't usually work in a consulting capacity. We often pass that on to people who are actual consultants. But we collaborate with people who are industries who have key questions. We get some funding, industrial funding, from a diverse group that includes oil companies, but also electric utilities and consultancies who want to see how they can make a business out of this. So, we try to answer very technically some of the same questions that you've been asking and we've been chatting about.
And we've been seeing a number of articles of CO2 sequestration. You were talking about stat gas, so I don't know what they call this other air gas, just harvesting from the general atmosphere.
Yeah.
And injecting, and there's like apparently a company trying to do that out in West Texas. There's that plant up in Iceland that is harvesting from the air and then injecting into some basalts and then actually fixing the carbon dioxide through precipitation of carbonates into the, although it seems like that could have porosity problems. But what are your thoughts on that? Are you involved in any of that kind of?
Yeah, of course. So there's been a lot of discussion since the last UN meetings about climate change, saying we probably are going to have an overshoot, put more CO2, put dangerous levels of CO2 in the atmosphere before we're done, before we get our act together. So what are we going to do about it? The need to draw it down has been discussed a lot. So these are carbon negative processes. Once the CO2 has escaped, you've let it up your stack, you've let it loose from agricultural lands or from other things. It's in the air. How are you going to get it back? So there's a lot of processes that do it naturally, like the oceans do it and turn it into carbonate. They turn it into, put it back in organics. They turn it, or plants trap it in soils, mineral weathering, but you can accelerate those things. So one of the proposed ways, all those things are proposed to accelerate, and we don't do them here, but we work with lots of people who are working on them. The two carbon negative technologies that need to produce enough CO2 that it needs to be stored are direct air capture, which is what you were talking about, Robert. Also bioenergy. If you capture the CO2 using biologic methods and then combust those biofuels. You need to, in order to keep them out of the atmosphere, you can capture them and store them. So direct air capture works just like capture from a stack, except it has to be tuned up to capture from the very dilute content of the atmosphere. Mm-hmm. It takes a fair amount of energy, so you have to be careful. It's not the solution. The clever person's solution is one of these basic things about telling your kid to dump the trash correctly in the trash can, not leave it around the house. So the putting it in the air is leaving it around, where it takes a lot more energy to get it back. So the smart thing to do is to do the capture from the point sources. Mm-hmm. It's already collected and concentrated, and get those out of the atmosphere, one. But then the remainder can be sucked out of the atmosphere. And the two things may need to work together to some extent. So the direct air capture and mineral trapping are certainly part of the portfolio. We need them times and places, but they're not the only thing to do. Sometimes people think, well, that's my favorite, let's just do that one. And this is a matter, my kids do this too. They come home, they leave things all over the house, and say, no. Put them away first. You put them away, and we're not picking them up later. So don't write off it's not as elegant or as flashy, but it's necessary to do first. Is deal with all the point sources, which, by the way, includes things like cement, or steel or plastics, not just the things you're thinking about that have coal or oil going straight into them, but these things, other things that handle large amounts of carbon, and have no choice but to handle the carbon. I want to tell you one other thing about why CO2 stays permanently. And this is a hydrologist thing. I can't look at Robert and say this with a straight face, because he knows, but I'll tell everyone else that once something goes into the microscopic pores, it's really hard to get it back out. It relies on a kind of physics that we all know about, but we didn't learn about in school, which is trapping us by capillary forces. This is especially true when there are two phases trying to share one little tiny space. They get in each other's way. They can't get out. So everyone's had this experience. It's why when if you should spill something like grease on your shirt, you can't shake it out. You can't wipe it out. It's stuck in those little spaces, right? Mm-hmm. The only way to get it out is to dissolve it out. You have to send it to the dry cleaner or use hot soapy water to dissolve it. It's very hard to get something out of tiny spaces. So when the CO2 goes in, it doesn't run out. You're putting it in the flower pot. The water that goes around the roots of the flower, you can carry that flower pot all around the house. The water doesn't come out. It's stuck inside, right? It's stuck in the pore spaces. So that fact that it goes down and gets stuck in those pore spaces is a really important thing to have in your mind, that why we can have confidence that this process will work. So it's physics. And just imagine, the other thing I think about is if you're putting mayonnaise on bread and you have 7 pieces of bread and you start too generously, the mayonnaise goes into the spaces on the bread, right? Mm-hmm. And you get to the 7th one, there's not enough. And you think, well, I'll just smear some off the first. No, try it at home. It's very hard to get that 7th sandwich enough mayonnaise. And that's because the little holes in the bread are pores. That's a pretty good way to think about what the rocks would look like, is the holes in the bread are down there, and the 2 phases of water and CO2 are sharing that space, and once in, they won't come back out.
Well, sounds like there's a promising future for CO2 sequestration. It's exciting that we're seeing activity in Texas, and although the Edwards Aquifer misses you, Dr. Hovorka, you're clearly doing noble work here to help us transition to more of a carbon neutral world. And so appreciate you joining us today and sharing your knowledge. And if anybody out there is looking to sequester some CO2, now you know who to call.
Put it back.
Put it back.
Thank you, Robert. Thank you, Carrie, for
Thank
letting me
you.
have this conversation, because people do need to know. If you have carbon you're emitting to the atmosphere, you should think about putting it back. Call whoever you're getting your stuff from and tell them, did they decarbonize your electricity, your products and things? Ask them.
Can we give them your number?
Put it back.
Put it back. Hashtag. I think you're starting a movement right here, right now, Sue. It's fantastic. Thank you so much for what you do.
Thank you.
Hey, Robert, I don't know about you. I learned so much from Sue. I know you've known her a long time, but that was awesome.
Yeah, that was so cool. The really fascinating work, and I may never think of the Earth the same again. Just I'm always going to picture a bowl of Rice Krispies kind of crackling.
Yeah, it was really neat and hopeful.
Yep, is hopeful. And it seems like Texas is just we've got the talent and the geology and the expertise with all these deep holes. That would be really good. We had a little bit of a discussion afterwards about whether fracked fields would be a good place to put CO2 in. And what did Sue say?
She said no.
No.
No, I wasn't. I asked her that question. I was just curious, and she said that the big repositories from kind of the old days when we had gushers, Texas had a lot of big repositories of gas and oil. Those big repositories are actually ideal. That fracked areas are more difficult to, as you might imagine, to access and understand.
Yeah, and it's I hadn't really. I mean, it was a great question that you asked, but I hadn't really thought about that but thinking about it kind of makes sense, because you're fracking formations that tend to be pretty tight to
Right.
begin with, and the fracking kind of helps loosen things up and pull in. So I think it's a lot harder. It would be a lot harder to push gas into the porous media than a what's called a conventional play or conventional field, where it's like a big broad sandstone that you didn't need to frack to get the oil out. There's been a huge amount of production, which means there's also a huge amount of it can take a huge amount of pressure to and kind of putting stuff back in. So
it's interesting too. I know we've mentioned this a couple times since we started the podcast, but this overlay of kind of the center of oil and gas here in Texas, and then the center of opportunity that kind of comes along with that. It's kind of an ironic partnership, but hopefully that means some of those players will turn their expertise to questions like these too.
Yep, I agree. So now it's time for our probably need some new theme music, right?
That would be good.
Our positive items. Each of us have a positive item. Do you want me to go first?
It seems like you want to. That'd be great.
Well,
yeah, sure, do it.
So it's not a news item. It's more of a kind of realization with a number of things going on. So we had the big meeting recently where the countries were getting together to kind of talk about how they're doing on the Paris Agreement and different things. I've also been involved in some discussions with City of Austin. I serve on a citizen group that kind of advises Austin Water on its water plan, which considers climate change. And so I've been on a subcommittee kind of working with city staff as well as the climate scientists they hired from UT and some others. And we're talking about what to plan for going forward. And I've been advocating. I don't know how this is going to go because we're still having discussions, but I've been advocating. I'm like, what is the most likely scenario going forward, and shouldn't that be what we plan for? And so, I feel like, I don't know where you feel, Carrie, but I feel like the world is not going to hit 1.5. We're going to, and by that I mean we're going to exceed 1.5. I think we're going to miss it.
Yes.
It just seems like there's been some studies that show it's a less than a 5% chance that we'll make it. But then the question is well, how bad is it going to get? And you look at some of those lines that they put out in projections, and some of them look awful. But looking at the expert assessments of promises that have been made so far, as well as risking, are countries really going to do this or not? Which of course there's interpretations there, and you can have agree and disagree, and yada yada yada. But it looks like we've kind of reached the point where we'll be under 2.5 degrees C. The 1.5 is a 1.5 degrees C, and you can roughly multiply those by 2 to get to Fahrenheit. And we'll be under 2.5 with the current likely implementation of promises. And so, I'm sorry, we're probably around 2C, 2 degrees Celsius with the current implementation of promises. And so that makes me feel optimistic. I'm not personally tied to, in my mind, the world does not end at 1.5 degrees Celsius. If it goes to 1.6, we're not going to be running around the streets on fire. It's not good because, because the more warming there is, the more consequences are going to be, and they're not linear. They compound, and then we're also getting, more and more into a temperature space that we haven't been in before, and the models aren't perfect, and so and there's been a lot of data that suggests the models have been more conservative than what's really been happening. But it when I look at the numbers and look at the projections, and having faith in humanity that we'll continue to do better with time, that our promises and our implementation is going to get better with time, that I'm hoping maybe we're somewhere between 1.5 and 2, and maybe closer to 1.5 than 2 going forward. So that's my positive note of kind of looking at data over the last few weeks, and projections, and what different experts are saying about it.
That's great. Well, that's comforting, Robert.
Okay, you didn't laugh too much when I said
Well,
that.
it's not that funny. It's not like ha funny.
Yes.
But I'm glad to hear it. I do trust your modeling skills, so that gives me some comfort.
Well, it's me looking at someone else's model, so I'm not modeling it, but like a lot of the first water plan that Austin did, it used the I hesitate to call it the worst case scenario, but it used the worst projection, and almost everybody doesn't think that's going to happen, which that's good news.
Well, that is good news.
So what good news do you have, Gary?
Well, though I'm not enjoying this whole juxtaposition of you being the optimist and me the pessimist, because that's not how I look at things.
I won't bring it up again.
But I did tell Robert with the apocalyptimist that I could maybe be an apocalyptimist. Which is, I don't think things are going to end all that well, but in the meantime, let's give each other presents and have a good time. So this article I found is all about holiday gift giving at the end of the world. And
at the end of the world?
Not really.
Okay.
It just says, gifts that might actually fight climate change. And it's a really good matchup with our guest today, because the first suggestion is that there is a company called Climeworks where you could pay about $96, and you can actually buy someone the gift certificate, basically, to put it back, like Sue said, put it back.
Mm-hmm.
So
put it back.
$96, and they put about 85 kilograms of CO2 back into the earth. So that's the first idea for gifts. And they're just talking about carbon capture and the storage technology that we just learned about being really crucial, even though it's a small part of the fight against climate change. It's a really crucial part. So consider that as a gift idea. And then I'll run through, I realize I do a lot of these lists, but I find these so informative. So donate to climate change organizations. Maybe give someone a transportation option that's a little greener. So give them a $20 gift card for public transit, maybe a used bike or an Amtrak gift card. Yeah, they talk about maybe focusing on more efficient electricity. And I don't know, for those of y'all listening, maybe you're like me, where maybe the rest of your family is not as interested in these topics. And um, so, gift giving season's a good time to help folks make the change, maybe to more energy efficient light bulbs or maybe solar charger for their devices. Just trying to think about how you can help folks make that shift. And they mentioned too low flow shower heads or a smart thermostat. And then for foodies, kind of going back to my last article, maybe give a vegetarian cookbook or something that makes it more interesting or fun to switch over to a little bit more plant-based eating.
Is there a climatarian cookbook yet?
Well, maybe we should write one.
Yeah. Oh, yeah.
And then their final tip was maybe give something that's been gently used or recycled in some way, So I hope that everyone has a good holiday, and there is a nice way to think about kind of how we can coexist with the reality of the shift that's happening and make better choices.
Yeah, and the thing, I still honestly believe that we can still enjoy kind of the lifestyles we have, but just thinking about how it could be done better.
Yeah.
Where it has a lower, if not non-existent, carbon footprint.
Yeah.
Well, good. That's kind of festive.
Yeah.
Andy. Yeah, very good. See, so it's a good thing I went first.
Well, here's to a new year, hopefully with less carbon and less COVID.
Yes.
And more good news.
More good news. And remember, put it back.
Put it back.
Till next time.
Bye,
I'm
y'all.
Robert Mays.
I'm Carrie Thompson.
And thanks to the Meadows Foundation for their support.
Good lady.